Hey, future students of 88 Tuition, welcome, welcome. As you can see, I prepared one is not really easy, but it's fun and it's challenging question just for you. Alright, so you're given only one piece of information, which is the radius of the circle is 5 cm. So from the center to the circumference of one small circle, it is a 5 centimeter. And it's supposed to use that to find the area of the regular hexagon. These 7 circles, they are of the same size. So all the radius are 5 cm, 5 cm, 5 cm, and so on. Alright, can you do it? Try. Alright, give yourself, let's say, 5 minutes to try this question yourself. Find the area of the regular hexagon. Now you press the pause button. Press now. Hey, never press, right? It's okay. Totally expected it. I knew it! Alright, so down here, let's discuss this question together, you and me. Alright, so let's try to unlock this question. Let's go. This question, right, relates to a few of the topics that you need to know. Like primary 4, you learn something called area of triangle. Yes, there's a little bit of area of triangle coming out later. Then you also need to know something. Sec 1, you learn something called polygon. Polygon will link to something called hexagon. If you never learn what is polygon, how you know what is hexagon, right? Oh, by looking at the shape, right? Clever you. Sec 2, you learn something called what? Pythagoras theorem. A squared plus B squared equal to C squared. Short squared plus long squared give you the super long square. Alright, Pythagoras theorem. Sec 3, you learn something called similar triangle. Yes, a little bit of similar triangle coming out also. And maybe you say, oh, sure, I learned also trigonometry in Sec 3 and Sec 2. Good for you. Maybe you can use that. I don't know. Alright, so you say that, okay, with this, right, in order to find the area of the regular hexagon, what should I do? Try to draw some lines. Try to cut it into triangles. Alright, so let's go. Let's see whether it works or not. So how do you cut? That's the next question. So maybe from the center of the center circle, alright, let me draw lines to the corner of the hexagon like this to form a triangle. Alright, let me cut it, alright, equally into the same congruence. Congruence means what? Exactly the same size triangle like this. Cannot? Happy? Oh, looks so good, alright. Lines look so straight. I know, right? Alright, so what do you see? Alright, you say that, oh, one round around the circle here is 360. What is one of these? 360 divided by 6, 60 degrees. So you managed to find one angle. Good for you. The radius is a 5 cm, which means that from the center to the circumference is a 5 cm. So down here, this portion is a 5 cm. Can? And from here to here, hey, that's the diameter lah. So down here is a 10 cm. Cannot. So the length is 5 plus 10, 15. I got 2 lengths, which makes the angle 60. I can use half AB sine C. Wow, getting excited. So you can say area triangle is equal to half AB sine C. I learned this in, Sec 3 trigo. Have you seen this before? Okay, never mind. So half AB, A is what? The 2 lengths. 5 plus 10 is 15. Another length, 5 plus 10 is 15. Sine, this 2 length makes the angle 60 degrees. So half AB sine C lah. Can? For those who are in Sec 1 looking at this, you can learn this also. Alright, it's very simple. The 2 lengths, which makes this angle, and the rest just leave it to your calculator. 0.5 times 15 times 15 times sine 60. And you should be getting a 97.4. Alright, 97.428 cm square. This is the area of one of this only. One of this portion here. Okay? Then you say, easy lah. Because they are the same, right? Times 6. So your argument will be 97.428 times 6. And that will be the area of the hexagon times 6. You will get a 584.567. Alright, give it to 3 significant figure. How come? Because this is an irrational number. You will go on and on and on and on again one. Alright, and you conclude that the area of the regular hexagon is 585 cm squared. Do you agree? Some of you disagree. How come? Some of you are very sharp. Don't have to buy sharpener already. You see this part. Alright, because this portion here, can you see? Okay, this is the what? On the right hand side down here. Okay, this is the sides of the hexagon. Your what? Your this line, right? The diameter only reaches where? Your diameter only reaches here only, the yellow part. Alright. So it simply means that what? it simply means that your 10 cm only reaches here. Then how about this portion here? Ah, yeah, so small, the length is negligible, don't care about it. So this portion, this area, don't care about it. Can you say that or not? Cannot, you cannot say such things, all right? We are talking about something called mathematics here. Mathematics here is about precision, all right? You have to be precise. You cannot say, ah, yeah, this small space, okay lah, don't count it in. So please, there is something wrong with this working here. I believe so. So let's try to prove the answer is not 585 cm squared, all right? Let's try to prove that the answer is not 585 cm squared. Let me show you the proper method. Shall we? Okay, let's go. So down here, again, you are right at the start. You have to draw some lines. But where the line to draw? What kind of line to draw? Sometimes you don't know, you have to just whack first. All right, just whack. Just go and find some lines to draw first. All right, so just now down there, it doesn't work right. Maybe I draw it downwards now. From the center of the circle, let me draw a line downwards like this. Okay, so this one, it comes down and it cuts the two circles in between, reaching the sides of the hexagon. Maybe draw another line here. Okay, so sometimes you don't know, just try and error, draw first. Hopefully you'll see something. Okay, and can I draw another one here from center towards the corner like that? All right, I did say that this topic, right, this question, right, is linked to topics like similar triangle. So try to form some similar triangle, try to form some right angle triangle because it might link to Pythagoras. All right, so can you see that there is a right angle triangle here already? Okay, so this portion is a right angle triangle. Is it okay? All right, so what can I see? I can see that the radius from here to here is a 5. All right, can I try to have another center of the circle here? Maybe it's there to assist me, I can try. All right, so from here, I draw one more line out here. Okay, let me draw a straight line. From here, let me draw a line outwards. Can you see? Can you see the similar triangle, small triangle versus the big triangle? All right, try to link it to it. Every time this type of tough question, right, you have to think of ways, you think of Pythagoras, you think of similar triangle. It's very useful one. Okay? So there's a small triangle here, and there's a big triangle here. My objective is to find one of the side of the hexagon. With one side of the hexagon, everything very easy to do already, really. All right, the problem here is that I do not have that information. I only have the radius of the circle, which is a 5 cm. It's not very helpful. Okay, so what do? So here, let me try to look at what information I have. So here is a 5 cm, okay. From here to here is a 5 cm. From here to the center of another circle is another 5 cm. So can I say that from here to here is a 10 cm? All right. So this portion to this portion, right, is a 10 cm. Is that true? Okay. From here to here is a 10 cm. Can you see that? Can Here to here is a 10 cm. Here to here is a 5 cm. Radius of the other circle, right? Radius is also the same. How come? Because it's the same circle, right? So down here must also be another 5 cm. So these are some information I try to put in first. Right? More information better than no information, right? Can? So knowing that this is 10 cm and this is 5 cm and this is a right angle triangle, can I kaypoly go and find this portion first? Can. Alright, so I call this O, center O. I call this A. Alright, I call this part B and I call this part C, can? So it's easier for me to do a comparison. And maybe this part I call it D. Okay, let's go. So using Pythagoras theorem, alright, this is a right angle triangle. 10 cm is the super long square. I need to take the short square plus the short square to give me the super long square. So let me go and find OA first. How do you find OA quickly? Some of you shortcut already very fast. Immediately you say that OA is equal to the square root of long square, 10 square minus the short square, 5 square. And that will give you, press your calculator. Alright, 100 minus 25, that will be a 75 inside. So down here, let me present as square root of 75. I don't want to press out the numbers, if not very long. Can? So OA here is actually square root of 75. Can? Taking the Pythagoras theorem rule, 100 minus 25, inside is still 75. The square root of it, that is the length of OA. Is that okay? Here I activate something called similar triangle. Alright, if you want, you can do a little sketch out of the triangle here. So I will sketch out a small triangle here versus another slightly bigger triangle. I know that the smaller triangle here is given as square root 75. I know that the base here is a 5. Down here is 90. What do I know about the bigger triangle? Yes, you know that this portion is square root 75 already. Do you know what is here? Can you see or not? From the center of this circle to the circumference, this is a 5 cm, right? From the center here to the circumference is also another 5 cm, what? So this portion is also 5 cm. Do you know that? Okay, let me bold my line. From the center of this circle to the circumference is also another 5 cm. Alright, that you have to see. So if this part is 5 cm, this part is also 5 cm, which means that the big triangle, yes, you are right, it's actually square root 75, alright, plus 5 centimeter. And what is the base? What is the base of this big triangle, which is here? Right, I don't know. That's what I want to find. If I can find this, I can times 2 to find the sides of the hexagon already. So I'm reaching there. So we call this what? We call this BC. Alright, so my objective now is to look for BC. What can you do? Very good. You do something called comparing similar triangle. So you compare what? You compare the height with the height, the base with the base. Shall we? Alright, so I compare 5, the base, with my base, BC. Small triangle versus big triangle is equal to square root 75, the small triangle's height versus the big triangle height, which is square root 75 plus 5. Alright, it's better to keep it in bracket, safety first. What do you see? Oh, I see single fraction on both sides. Single fraction equals single fraction cross multiply. That's what I always say. Alright, so down here I have BC times what? BC times square root 75 is equal to 5 times the bracket, square root 75 plus 5. Okay, so the reason for cross multiplication is to make it into one single line, easier to solve. Then I can successfully find my BC already, lor. Down here, BC times square root 75 times you bring across is a divide. So you have 5 square root 75 plus 5. Can you see I don't want to press my calculator first, later then press one time. Over, times you bring across is a divide. Divide by square root 75. And this whole thing is the length of BC. Can you see that? And this one you can easily press your calculator. 5 open bracket square root 75 plus 5 close bracket, the whole thing over square root 75. Can we do that now? Come, press your calculator. Everything all in. 5 open bracket square root 75 plus 5 close bracket. Put the fraction key over square root 75. Your answer will be 7.8867. Alright, so this portion here will be equal to 7.88675. Alright, it's better to write a little bit more decimal. Alright, so that we try to be as precise as possible. So this calculator, this number, right, don't go and erase it. Just keep it there first, we might need it. So knowing one of these, we can find the rest already. How? Alright, this and this is the same. So if I draw another, alright, if I draw another line down here, what do you see? Okay, you can see that it is a what? You can see that it is a full triangle, right? Can? So can I go and find the entire base first so that I can use my primary 4 method? Half times base times height. Do I have the height OB? Yes, I have my height OB, which is what? Square root 75 plus 5 what? Can? Yeah? Alright, so let me go and find the entire length here first. Alright, for the base. So we call this, we have A, B, C, D. Can we call this E? Alright, call this E. So let me go and find my CE first. CE is actually equal to this number here, 7.88675 times 2. Okay, that will be equal to 15.77. Write a bit more decimal, 35 cm. Okay, so I have my entire base of CE already. Can I find the area of one of this triangle times 6? Yes. So if you can, immediately go and find the area of hexagon already. Area of hexagon is equal to, okay, you go and find the area of one triangle first. Half times base. Base is 15.7735 times height. What's the height? The height of here is called OB, right? OB is actually here, OB. All right, you keep a bracket on, square root 75 plus 5. Okay, so this portion here will actually give you the area of a triangle. Then what must you do? Times 6, very good, because it is 6 congruence triangle. So the whole thing must times 6. And that will give you the answer. Okay, so I key in my calculator. This 15.7735 is in my calculator already. I key in times 0.5 times open bracket square root 75 plus 5. Close bracket. Alright, this whole thing times 6 again. Answer is 646. Okay, so my answer for here is approximately 646 cm square. To what? To 3 significant figure. Okay, and you present your answer as 646. Woo! 585, 646. Ah, quite close. Close, man. You think so? No. Alright, so this is the correct answer. We can say that this is the incorrect answer. Can you see that? So you have learned how to find the area of a regular hexagon with just one information. That is the beauty of mathematics. You know so many different topics coming together just to form one question, you know. And from one clue, you are able to find out the answer. Wow! Do you think that it feels good? Oh, only I feel good. No, right? Come on, it feels good. So next time, if this question comes out for your exam or maybe even your O-level, wow! Can you solve? You have the basic idea already. Okay, must learn to draw some lines. After draw some lines, try to form a right angle triangle, try to form some triangle, try to what? Use something called similar triangle. Look for the similar triangle involved. Alright, got similar triangle? I can use it to assist me to find out the final answer. Can you see? And one thing leading to another thing. Different topics merging together. Whoa, math is so fun. Do you think so? Yeah? Alright, so this is one quick questions, not very quick, I know. All right, one quick question or one challenging question that we will always try to do, all right, inside the entire syllabus, inside the entire video, the program and all this. All right, so I hope to see you once again in the real actual video. All right, this is just a demo just to entice you to watch more of me. All right, so I will see you hopefully in the actual video. In the meantime, you continue to, learn something more, all right? Don't give up on learning and keep pushing yourself forward. You can do it, all right? I trust in you.